Hi, I'm Mr. Roche, and welcome to Mr. Roche's Flip Class, Math 10, No Frills, No Thrills, Low Check, Low Budget videos. Today's topic is polynomials, and more specifically, we're going to be multiplying polynomials today. Joining us today is Wilson. He's really happy today because he's going to learn how to multiply some polynomials. So I'm going to sit him down there where he's comfortable, and I hope you join us. Here we go. Comfortable, Wilson? Yep, good. Okay, so today we're going to start off by multiplying monomials. I'm going to show you how to do that with algebra tiles as well as algebraically, and then we'll move on to multiplying polynomials by monomials. First, multiplying monomials. Let's start with a simple numerical example of monomials. The question 3 times 4 equals 12. Well, everybody knows that. But we can illustrate that using a rectangle. In fact, we can use a rectangle to illustrate any product of two numbers or monomials. So, if we have 3 by 4, those are actually the dimensions, the length and width of the rectangle. 3 by 4, of whatever units, inches or centimeters or whatever. So where does the 12 come in? Well, 12 would be, if I fill this in, I have 3 units this way, and 4 units this way. So 3 by 4, or 3 times 4, is 12. So the 3 and 4 are the factors of this equation, or the dimensions of the rectangle, while the 12 is a product of that equation, or the area of that rectangle. Now we can actually do much more complex things using our algebra tiles, so we can get in some algebraic terms. So Wilson, will you do me a favor and grab that camera, and we're going to go over there to where the algebra tiles are set up. Okay, right here, Wilson, on this one, please. Are you ready to go? Okay, so I call this guy Matt, and he's actually our algae organizer, and here's how it works. There's 3 levels here. There's this top level, and that is actually like a frame, like a picture frame that goes all the way around. That has no significance. Then we have like a step along here and here. And those 2 steps are where we put our dimensions down, or our factors. And then finally we have this lower level, or this plateau, or the big flat here. And that is where we're going to put our area, or our product of our equation. So here's an example. Come on over here. This is the same example we did on the board just now, 3 times 4. Now remember, back in elementary school we learned that that means 3 groups of 4. So here we have a 4, and here we have a 3. So these are my dimensions on those stairs. Now the area will be something that is this wide and this long, or vice versa. So I'm going to put in one layer first. Whoops. Okay, so you can see that we have one group of 4. Now we have 2 groups of 4, that's 8. And finally we have 3 groups of 4. So 3 by 4, or 3 times 4, is 12. 12 is the area, or the product. Okay, now let's bring in some algebraic terms into here. So if you can come down here, Wilson. Okay, this is 3 times 2x's, or 3 groups of 2x's. So here's my 2x's, and here's my 3. So I'm going to go along and fill this in. So I need pieces that are this long and only 1 wide. So that's where these X tiles come in. Oops. There we go. And there we go. So that's all filled in now. So the rectangle that has an area of 3 by 2 x's is, if I count all that up, 6 x's. So the answer to that question, 3 groups of 2x, is 6 x's. Done. Okay, come on over here. We'll multiply 2 algebraic terms together. So this time we have 2x's times 3x's. 2x's times 3x's. And something that is that wide and that long, or high, would be something like this. Notice the x squared is x by x. And we have another x squared, and another one, and another one, and another one, and another one. So the product of 2x's by 3x's is 6x squareds. 6x squared. Notice 2 times 3 is 6, and x times x is x squared. That's not a coincidence. Okay, bring the camera up here, Wilson, and we'll conclude what we have so far. You got this, Wilson? Okay? Okay, so in conclusion, when multiplying two monomials, multiply the two coefficients first, then multiply one variable power at a time, remembering to add their exponents when you multiply powers with the same base. So here's some examples. Now we can do this example. These are much too complex for algebra time, but we can use the same process. So for example, 5x times 7x. 5 times 7 is 35. X times x is x squared. Done. We could do the same thing using the algebra tiles. In this case, negative 4 times 7 is negative 28. And x times x squared, remember this is x to the 1 times x to the 2, is x to the 1 plus 2 is 3. So negative 28x cubed. In this one we have negative 10 times 5 is negative 50. X to the 3 times x to the 6. 3 plus 6 is 9. Done. And finally this one, negative 4 times negative 3 is positive 12. X to the 2 times x to the 2 is x to the 2 plus 2, which is 4. Y to the 3 plus 4 is 7. And we have z times no more z's is still z. Or z to the 1 and z to the 0, which is still z to the 1. Okay, now we're going to move back over to the algebra tiles and look how to multiply a polynomial by monomial. Ready, Wilson? Okay, we're over here. Okay, in this case, you okay there? We have a polynomial, which in this case is a binomial, times a monomial. So this literally means three groups of 2x plus 2. On the tiles here, you can see that we have 1x, 2x. So here's my 2x plus 2, my binomial, because it's made up of two different kinds of parts. And here's my monomial, which is just 3. So if I fill that in now, there's one group of 2x plus 2. There's two groups of 2x plus 2.
Reminder to Junior Jazz Band, there's rehearsal right now in the music room. Junior Jazz Band members.
And there you have it. Three groups of 2x plus 2. So what do we have altogether? We have 6 x's. And we have 6 1s, or plus 6. Notice if we went 3 times 2x, we would get 6x, or 3 groups of 2x. And 3 times 2, or 3 groups of 2, is positive 6. Okay. You probably remember from previous years that that's called a distributive property. Okay, let's try something. This is as difficult as we need to get right now. 2x times x plus 4. So again, a monomial by a binomial. So x plus 4 is represented here, times 2x. If I fill all that in, I'm just going to do it as quickly as I can now. And there we have it. We have 2x squareds and 8 x's. And again, we can confirm that by going 2x times x is 2x squareds, and 2x times positive 4 is positive 8 x's. Okay, Wilson, that looks pretty logical. So let's go back up to the board now. So, when multiplying polynomials by monomials, we simply use the distributive property. So remember that a times b plus c, that a would be multiplied by b to get ab, and a would multiply by c to get c. And if there was more than just 2 terms, if there's 3 or 4, you'd multiply that a through every one of those terms in the brackets. Okay, so let's do a final few examples. So 3 times 5x is 15x's, and 3 times negative 4 is negative 12. Okay, on to here. Now this is a trinomial times a monomial. 7x times 3x squared is 21x cubed. 7x times positive 2x is positive 14x squared. And 7x times negative 1 is negative 7x. Negative x squared times 5x squared is negative 5x to the 4. negative x squared times negative 8x is positive 8x cubed, and negative x squared times positive 2 is negative 2x squared. And finally, if you mixed up variables here, that times there would be 6x cubed, because 1 and 2 more is 3, y, because there's some y in there as well, minus 2xy cubed. So, hopefully that looks pretty good. Wilson, you understand? He's got a big smile on his face, so I guess he understands. So that concludes my video for today. The next video, part 3, we'll be examining multiplying binomials and multiplying trinomials by trinomials and all sorts of stuff like that. So thanks for now, and thanks for joining Wilson and I. Until next time.